I'm Ben,
I'm Avtaar.
and this is our video tutorial for BC Calculus. We're going to show you guys how to do trigonometric substitution, integration by parts,
L'Hopital's rule and
ratio test.
ratio test. There you go.
So hope you guys enjoy.
Now I'm going to show you how to use L'Hopital's rule, which is a rule that you use when the limit of the function as it approaches c is equal to one of these indeterminate forms, either infinity over infinity, 0 over 0, 1 to the power of infinity, 0 times infinity, 0 to the power of 0, or infinity minus infinity. And if it's in any of these forms, you have to manipulate it until it's in one of these two in order to solve to get your limit. So in order to get the answer, you have to take the derivative of the top over the derivative of the bottom. So in this example, we have the limit as x approaches infinity of e to the x over x squared. So first, we'll plug in infinity to see if it's in one of our indeterminate forms. Which it is. It's in the form infinity over infinity. So we can take the derivative of the top over the derivative of the bottom, which is e to the x over 2x, and plug in our c value, which is infinity again, which is e to the infinity over 2 times infinity, which is again infinity over infinity. So we're going to use L'Hopital's rule again, taking the derivative of the top over the derivative of the bottom of this equation, giving us e to the x over 2, which is equal to e to the infinity over 2, which is equal to infinity over 2, which is equal to infinity. And that's our answer.
I'm going to go over trigonometric integrals. You can find them in section 8.3 in the Brown book. So this is just when you take the integral of sine x and cosine x to a power, or secant x and tangent x to a power. So page 540, you can see some problems that they have. So what I do first is I try to use u substitution. That's like the first thing I try to do. So in number 5, you can just set u equal to cosine x, and you'll get du equals negative sine x. And then you can just put negative du equals sine x dx. And you can integrate it that way. It'll just be the negative integral of u to the third. So on number 5, u substitution would be the method to use since it's easier. But if you look at problems like number 9, both sine and cosine x are to a power. So these are the problems I'm talking about. So this is where you would use the identity cosine x squared plus sine x squared equals 1. So whenever you have a sign that's odd and positive, you want to convert them all to cosine. So then you use sine x as a factor, because then you'll set u equal to cosine x, and negative du will be sine x dx. But when the cosine is odd and positive, then you use what do you call it? Like in number 6, then you use you convert them all to sine, and then use the cosine x as a factor, because then you'll set u equal to sine x, and du will equal cosine x dx. So yeah, I did number 9. I'll show you guys what I mean. And number 9, so it was the integral of sine x to the 5th plus cosine x squared dx. So I wrote it in a different form. I wrote, since I know that sine squared x equals 1 minus cosine squared x, I wrote it out like that. It's still the same thing. It's still sine to the 5th x, but it's written, because this is sine squared x, this is sine squared x. So that's like sine to the 4th x times sine x. It's still kind of the same thing. It is the same thing, but it's written in a different form. So then what I did was I just multiplied 1 minus cosine squared x times 1 minus cosine squared x, and I got that right there. And then I multiplied that with the cosine squared x, and I got this right here, and then I use u substitution. I set u equal to cosine x, and I got negative du equals sine x dx, and then you basically just take the integral, and once you get the integral, I got negative u to the third over 3 minus 2u to the fifth over 5 plus u to the seventh over 7 plus c, and then I just distributed the negative, and then I just plugged in cosine x. And that's basically how you do a trigonometric integral when both sine x and cosine x are to a power. And then you do the same with secant x and tangent x. Like you try, like number 33, you can use u substitution. Since we know the derivative of tangent x is just secant squared x, we can just set u equal to tangent x, and then du would be secant squared x dx, and it'll just be the integral of u. And then depending on what the power is, you convert, like in number 35, 37, 39, it depends on the power, and you just convert it, you just use the identity 1 plus tangent squared x equals secant squared x, and it's kind of the same principle with that as it was with the cosine x and sine x. Yeah, and that's pretty much how you do the trigonometric integrals.
Okay, so I'm going to be showing you how to do integration by parts, which is a method that you're going to want to use if all of your other basic methods of integration fail. So you want to start by writing your integral, which in this case is the integral of x times the natural log of x dx, and you want to separate it into two parts, setting one part equal to u and one part equal to dv. So in this case, since we know the derivative of natural log of x, we're going to set u equal to natural log of x, and since we know the integral of x dx, we're going to set dv equal to that, and then we're going to solve for that, which v is equal to x squared over 2 and du is equal to 1 over x. Once we do that, we can plug it into our formula, which is uv minus the integral of v du. Once you do that, you just simply plug in your numbers, which is that minus the integral of v du, which is x squared over 2 minus, or times 1 over x, which simplifies to x squared over 2 times the natural log of x minus 1/2 the square root of x, the integral of x dx. Then you simplify it further, and that's your answer.
Now I'm going to go over how to find the interval of convergence. It's in section 9.8 in the Brown book. So when I find the interval of convergence, I usually use the ratio test, but I think you can use the root test and the geometric series test too, but I like using the ratio test. And I just want to point out that the radius of convergence is different than the interval of convergence, because on the AP test they'll ask you for the radius, but they'll give you the answer for the interval, so they'll try to trick you. So I just wanted to point that out. And so I did number 19 here, and so what I had was, I had this series right here, and they asked me for the interval of convergence, so I used the ratio test, so which is you just add 1 wherever there's an n value, and then you divide it by the original equation. And it's the limit as n approaches infinity of all this stuff. And then after you simplify, after I simplified it, I got the limit as n approaches infinity of negative x over 4. And so you when the limit equals 0, the interval converges everywhere, but in this case there's no n's, so it doesn't matter. And when the limit equals infinity, it diverges everywhere, so then there's no interval of convergence. So I just wanted to point that out too, because sometimes the limit will equal 0, so you gotta, then the interval equals, the interval of convergence is from negative infinity to infinity. But since there's no n's here, I'm just gonna move along with the problem. And So I got negative x over 4 is less than 1. I times it by 4, and the radius is 4 because it's in the form of the absolute value of x minus c is less than r, and r is the radius of convergence, and in this case it's 4. So then I just solved the problem, and I got negative 4 is less than x is less than 4, and that's the interval I got. And then you plug in negative 4 into the series and see if it converges or diverges, and then you plug in 4 and see if it converges and diverges, but I found that they both diverge, so you don't include them in the interval. So